All right, so today's notes are on synthetic division. Our content objective is to divide polynomials using synthetic division, and our language objective is to use the correct terminology to describe that process. So I want to do a quick overview of synthetic division. It is still dividing polynomials like we did with polynomial long division. It just takes that process and simplifies it by omitting variables and exponents. So basically it takes the same process of polynomial long division, takes out the variables and exponents, and makes it simpler. So I want to note before we jump into this, I'm only showing us examples where we are dividing by a linear factor in the form x minus a. So you can't divide by x squared, you can't divide by something like 2x. I'm strictly focusing on when it's in this form, and there is a more complicated process we can do if you want to divide by polynomials with 2 or x squared or something. But for all intents and purposes, we just need to know this part, and then you can use polynomial long division if you need to encounter something with a coefficient or an exponent. We can talk about that more in class. But today we're focusing on dividing by linear factors in this form, so x cannot have an exponent or coefficient other than 1. So what we're doing today in this lesson is focusing strictly when exponent and coefficient of x are 1. So first thing you need to remember is always start by switching the sign of a, so this a, so that you can add instead of subtract. So we'll jump in with an example so you can see what I mean when I say that. But that's always going to be your first step. Please don't forget to do that or it'll mess up your whole process. So we're going to divide x cubed minus 4x squared plus 51x minus 54 by x plus 2 using synthetic division. So the first thing I need to do to make this happen is, like I said, switch the sign of a. So instead of using plus 2, it becomes negative 2. So I'm going to put this negative 2 in a box, little box here. And I'm going to write the coefficients of the original polynomial. Right. The other thing I want to note is put 0 for skipped degrees. So here it goes straight in order, so I don't need to put a 0 as a placeholder. So just like we did with polynomial long division, if there is a skipped degree, you should put 0 as a placeholder. We don't need to deal with that here, so I'm just going to write coefficient of x cubed is 1, coefficient of x squared is negative 14, coefficient of x is 51, constant is 54. So I write out all those coefficients, and then I'm going to draw a little line here to make sure, oh, you'll see why in a second. But I'm going to draw a line, actually, sorry, let me draw it here. Sorry, but my dog. So I'm going to start this process by bringing down the first coefficient. So this 1 I'm going to drop to here. So I'm just going to drop the first coefficient, and then I'm going to multiply negative 2 by that number. So I'm going to do 2 or negative 2 times 1, and then I'm going to write that here. So negative 2 times 1 is negative 2. So I'm going to write that there, and then I'm going to add down. So then negative 14 plus negative 2 is negative 16, and I'm just going to repeat that process. So then I do negative 2 times 16 is going to be positive 32. I add those down, I get 83. I multiply those and I get negative 166. I add those down, I get negative 220. So now I've repeated that process. I did this, got here. I'm just multiplying by the number dropped, writing it here, getting a new number, and repeating that process each time. After I finish going through all of them, I'm going to write my new polynomial. With each term, or each coefficient, 1 degree less than its original. So originally this 1 was with x cubed, now it's going to be 1x squared. Originally this 14 was with squared, so it's going to be minus 16 plain x. Then I'd have plus 83 as the constant, and I'd have a remainder of negative 220. So this would not be a factor of this term. So since I have a remainder, it's not a factor of this polynomial, but I've successfully divided it. The other way, so then you don't need to write the 1. And the other thing you can note is if you have a remainder, you can also write this as minus, or since it's negative, minus 220 over what you divided by, so x plus 2. So you can also write it that way as your remainder, since that's what's left over, is that over 222, or 222 over what you divided by. All right, so that's our first example. I'm going to do a quick check. So I'm going to flip the page, do a quick check. I want us to divide x cubed plus 7x squared minus 38x minus 240 by x plus 5. So if you can try that on your own, that'd be great. I'm going to go over it now. So I start by switching the sign on the 5, make it negative 5. I write my coefficients across the top, so I have 1, 7, negative 38, negative 240. I draw my line here, drop my first number, and now I'm going to start multiplying. So negative 5 times 1 is negative 5. 7 minus 5 is going to be 2. Negative 5 times 2 is going to be negative 10. Negative 10, or negative 38 plus negative 10 is negative 48. Negative 5 times negative 48 is going to be positive 240, which those then cancel out, and I have nothing left there to write. So I end up with x squared plus 2x minus 48 as my answer. The other thing you can note is the factored form of this would be what I started with, x plus 5, times what I got. So x squared plus 2x minus 48. So again, just to tie this back to how we're using this, we can use it to solve polynomials because we can now factor it and use the zero product property, whereas we couldn't do that with our original cubic function. So by using polynomial long division or synthetic division, dividing polynomials, you can get to factored form, which allows you to solve. Just to tie this back to why we're learning this. So the last thing I want to go over with synthetic division is the remainder theorem. So the remainder theorem, really quickly, just says that if you divide a polynomial by x minus a, then the remainder is the same as the value of p of a, or the function evaluated for the value a. So whatever a is, instead of plugging it into your polynomial and spending all this time raising it to powers and calculating it out, you can use synthetic division to figure out what the remainder is and figure out what that value would be. So to show you what I mean, we'll do a quick example. Given that p of x is equal to x to the 5th minus 2x cubed minus x squared plus 2, what is p of 3? So I want us to use synthetic division to figure this out. So what I'm going to do, I'm just going to write one step really, is divide by x minus 3. I also want to remind you, put placeholders for x to the 4th and x. Since we skipped over x to the 4th, we skipped over x. Make sure you put placeholders for those. So x minus 3 That's what I'm dividing by. Since it was originally 3, I switched the sign. So when I plug it in, it's actually just 3 again. So if that helps, you don't need to double switch it. You can just keep whatever's here. That's what you're going to divide by or put as your value in there. So then I'm going to write the coefficients. I have 1. Again, I have to put 0 as a placeholder for x to the 4th. I have -2, -1. I put another 0 for the placeholder for x, and then I have 2. Draw my line, drop the first one. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. -2 plus 9 is 7. 3 times 7 is 21. -1 plus 21 is 20. 3 times 20 is 60. 0 plus 60 is 60. 3 times 60 is 180. 2 plus 180 is 182. So since this is my remainder, P of 3 is equal to 182. So that's how I can use synthetic division to figure that out. So I know instead of plugging in 3 to this whole thing and calculating it out, I can do synthetic division and get that value. Just to prove to you that this works, you can check this last part. I can check by actually plugging it in. So P of 3 would equal 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2, which becomes 3 to the 5th, if you know it, is 243. 3 cubed is 27 times 2 is 54, so minus 54 minus 9 plus 2. 243 minus 54 is 189 minus 9 plus 2. 189 minus 9 is 180 plus 2 is 182. So again, you could use either method, but I think you'll find the larger polynomial you have, the easier it will be to use synthetic division instead of plugging it into your polynomial. That's all for today. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.